Cool. So now you have everything you need to try to run a blade optimization loop, to try to run Ashes in Matlab to run an optimization loop. And what we have done is that we've made an example, simple Matlab script that's going to do just that, and you can find it in. So here, if you go to your Ashes folder, Ashes-21, you'll have Ashes-cli examples, and then blade optimization example. Okay, and this is the file. And I mean, it's a pretty simple script. It's just gonna assume that you have a blade that has a constant twist, and starting with a twist of 0 all along the blade, and then just like change the twist little by little and find what's the twist that gives you the best power coefficient. So I will run you through the script. Hopefully the comments will help, but I'll run through the script in detail as well. So as always, the first thing that we need the two things that we need to run Ashes-cli are a model and a CSV file. So the model, you have it here, so I can open it in Ashes, and you will see it here. So this is my base model. It's it has 4 blades because why not? And then you can see that the blade initially has like a constant twist of 0 and a constant airflow as well all along the blade. So that's my default model, my base model. And then the second thing that I need is a CSV file that's going to define the batch, and that's what I have here. Produce CP curves. I can open this, and then here you will see that the only parameters that we're going to change, maybe I can make this a bit bigger. So we're just going to be changing the blade, so that's why I have the blade parameter here. I have the make rotor CP curve parameter here set to true, so that was from a previous video. And I'm also setting the rotor model to stiff, and that's, as I explained before, is because I want to ignore the structural properties. This is kind of redundant because actually if you come to the model, you will see that I have also set the rotor model here to stiff. So because the base model already has like a rigid blades, then it doesn't really matter that I add it here again. So I just put it, in case I forget it in my base model, but it is redundant in this particular case. But so these are my two things, okay? The CSV file and the base model for Ashes. Cool. So I can close this, and if I go to my Matlab script, so the way I have done it, there's probably several ways to do this, but the way I have done it myself is that I have a header file, and I'm going to explain why now in a second. So here, so this is the shape file that we've seen in the previous video. As you remember, it has 3 sections: the airflow sections, the blade length section, and the aerodynamical sections. So what I have created is what I've called a header file, which doesn't have the last section, it doesn't have these aerodynamical sections, and it doesn't have all the comments, and that's what it looks like, okay? So it just has the sections here. Because this blade is really simple, it only has one airfoil, so that's why there's only one element here. The blade length is 60, I'll just pick this number. And then this is what I've left empty, because this is what I'm going to be changing in my Matlab script. In the script, I'm gonna take this file, copy it, and then add the aerodynamical properties. And whenever I add them, this is what it's gonna look like. So it's the same file, but I've just added a table that has the properties. So yeah, so if I go back here, this is what I've defined, all these files that I've shown you. So these 3 files, and yeah, just the name of the blade here. Then that's the 2 elements that we need to run a batch from the CLI, so the model and the CSV file for the batch. This is where we create the section that I showed you before, the aerodynamical stations section. So you know each of these vectors is going to correspond to one of these columns here, and you can see that you know the first three, as I explained in a previous video, can just be set to zeros, and the twist is the one that we're going to be changing. The chord length is constant equal to 3, so that's what you can see here. And then the airfoil nickname, we only have one, so it's going to be this one here. So that's what this does. Then this bit is just to create the figure. This here will contain the legend. And this vector is the one that will have the different twists. So we start at 0, and then we're going to run one blade with 0 twist, 0 constant twist, then 2, 4, 6, and so on, all the way to 10. This is just to check what the best values are. So every time I run a new simulation, I'm going to check what the maximum CP is and store it. If it's better than the current maximum CP, then I store it. So I initialize this at -1. If these things don't make too much sense, I mean, you can always run them, put a breakpoint, and kind of check the values as the script goes. Okay, and then it should make sense. And then here, excuse me. And then here, that's where we start running iterations. Okay, so we're going to be running simulations for each of the constant twists that were defined in this vector. And in every simulation we're going to create a CP curve, and then we're going to check the results. So first, to copy the file that had the header that I showed you, we're going to copy it and then modify it. So that's what this does. It copies it, then we create the aerodynamical stations section, and then write it on the shape file. So once we've gone through these 3 lines, you will have this file here, which is defining the blade shape. So now that I have created my shape file, I can add the blade to the database, and for that, yeah, I will add the shape file and the structure as well. So I didn't show you, but there is also a structure file here. Because we're ignoring it, it doesn't really matter what it contains. It just needs to have the correct format. But so yeah, so I add my blade with the shape and the structure. Then I run the batch with the CSV file that I showed you before, so that it's going to create the CP curve. This is just to read the curve that I've created. So here the results, I'm saving them I'm leaving the default path to save the results in Ashes. So that's what it is. But you could go to Ashes and change that if you wanted. And yeah, so once I've read the CP table, I can put the values into 2 Matlab variables, add that to my plot, to my figure. And then check here, you know, if the blade that I'm currently testing is better than the previous one, then I save it, and if not, I just don't care. Remove the folder. So this is the folder that contained the results from the simulation, and by default the folder is going to be called produce CP curve. But if you run a simulation and there's already a folder called like this, then it's going to be called produce CP curve like this, and then with a number in parentheses. So in order for that not to happen, what I do is that I always remove the folder that was created, and so that way, you know, I know that this is always going to be the folder where the results are saved. Yeah, this one here. And yeah, then remove the blades from the database. Add modify the legend. I mean, this is just for the plot, so it's not that important. This is to show the progress and plot in the figure. So showing the progress is just gonna display like a little percentage here. So yeah, so if I run my simulation now, okay, you can see how this is running now. Successfully added to the database. Then I get my little progress percentage here, and then move to the next iteration. So, you know, here we've removed the blades, and we add the blade again. And then yeah, we can wait until this this is finished. Okay, so now the simulations, all the simulations are finished, and this is the graph that shows all the CP curves for all the different constant twist angles that my blade had. And yeah, from here it seems like the best result was obtained for, so it's the yellow line here, which is a constant twist of 4 degrees. And yeah, 47%, so that's not too bad. And then I guess that if I come here, so best blade, that's the and you can see that it has a 4 degrees here as a twist angle. Cool, so yes, that's the end of this tutorial. I hope that this is helpful. If you have any questions or any doubt, please do write questions on the forum. Don't hesitate, we'll generally answer really quickly there, so do that, and we'll help with whatever we can. Good luck with everything, and see you around.